Video lesson for 9.3. So for today, we're going to do basic log rules. So I have them up here at the top, the three rules that we're going to be looking at. And these allow us to do one of two things. We can either expand a log expression or we can condense it. So right now for today, it's just a matter of kind of learning the rules, just kind of getting the process down as to what to do. And then we'll start developing the process a little bit more and utilizing them. When is it better to condense? When is it better to expand? That kind of thing. So let's look here for the first one. So power rule, all right? If you notice here, I can take the exponent. So the exponent that I have here, I can power it down. I can put it in front of the log expression. That gives me that n, and then I can just multiply that by whatever the log that I have for that. So if we look at this example here, right, 9 raised to the fifth. Now, honestly, this is something you could obviously do. You can take 9 raised to the fifth power and get a number, and you could take the log of it and actually find out a decimal. But a lot of times we'll have variables or something in there. So to just for now, just to rewrite this, I can take this, I can rewrite it, and say that that's 5 times whatever log base 2 of 9 is. Right, and that allows us to kind of just simplify the expression or manipulate the expression and to do something else if we needed to. Like I said, this one specifically, we could actually just plug into the calculator and find the decimal, but again, we're not worrying about that at this point in time. Another example, let's see here. I'm just going to kind of bounce around a little bit to try to show each one of these. Let's do product rule here. So if product rule says that if I have the product of two things, I can break that up as to the log of the first term plus the log of the second term. Notice that the bases, like log b here, is consistent throughout the out. So whatever this is, it has to be the same for all of them. So let's do 21. So I'm just going to break this up, even though, again, this is another one we could have just plugged into the calculator and got a decimal answer. But let's just rewrite this. Let's say that that's log base 2. 21 is the same thing as 3 times 7, right? So we could say and expand this and say, well, log base 2 of 3 plus log base 2 of 7. So that would be an expanded version or of what that log is. Like I said, we could actually plug them in and get them, but I'm not worried about the values at the moment. I'm just worried about being able to actually rewrite or break down the logs. Last rule here we have is quotient. Same kind of concept, except here I have something where they're being divided. And then when I can break them out into two logs, individual logs, but this time they're going to be subtracted. So looking at number 2, all right, that allows us to say that this is going to be the log base 5 of the numerator minus log base 5 of the denominator. And that would be the expanded version. And like I said, you could plug them in because you actually have numbers and actually solve them from there. So if you look, I'll let you guys try and work the rest of some of these out on your own. Notice now you have a variable here. So obviously this one is not something you just plug in the calculator and get an answer for. So you would have to be able to expand this out, try to simplify the process. That's a product. Here you've got two things happening. You've got quotient. Actually 3, sorry. You got quotient, you've got a product up here. You also have an exponent down there as well. So I'm going to be honest with you, this one's got all 3 rules happening. So this is going to get expanded pretty far. And here I would rewrite anytime I have a radical, I personally like to write it as a fractional exponent. Makes your life a lot easier. So I would utilize that, and then you can use the different rules to kind of break that down. All right. For these other next set, 7 through 12, this is where you want to condense. So I want to go backwards. I want to use these rules, but I want to make them from the expanded, aka the right sides here, I want to make them into the left sides, the condensed versions. So here, 2 times a log, that means that I could rewrite this as simply making that the exponent. That's the power rule, backwards, right? And then I also have here that you have them being subtracted. So that would be the quotient rule. So if I'm going to get this one to be a simplified answer, we're going to have log base 3 of 10 and ends up being squared, right? So that's 10 to the square over the denominator, which is 4. right? When we have these, we can obviously then simplify this. So this is going to be log base 3, 10 squared is just 100 over 4. So that's log base 3 of 25. And now that would be your, condensed and simplified version of that process. All right, let's try a different one. Let's try 10 here. All right, for this one, so over here. So I got, once again, I've got something being multiplied to the log itself. So I could rewrite that as an exponent. And then here we've got addition of 2 logs. Again, notice they have the same bases. I couldn't condense this if they were not the same bases. So they must have the same. So therefore, they are going to be the same. So now I can say that this is equal to, let's say, log base 2 of, so we're condensing. So we've got x raised to the 2/3 times y. All right, so that is in fact our condensed version. A lot of times people want to put parentheses around, that's fine. As long as it's organized and neat, you should be okay. And that's the process there. All right. I'm just realizing here, this should have a addition sign here. So add that in there. There's a plus sign there. All right, so I'm going to let you guys try some of those. Some other key facts, things that you need to make sure you know. Log, let's just say like log of x here. Notice that if there's no number here, right, is base 10, right? If there's no number, that's a base 10. This rule applies to natural logs as well. So natural log of x, that has here, that's equivalent to log base e of x. So when we're dealing with a base of e, that's a natural log, right? An important fact to know is that the log of e is equal to 1. That's a fact that's really important to know. And what else? I feel like we had something else to write down. We can have some other ones. The natural, I'll keep it the same color here. Natural log, another important fact is natural log of 1 is 0. And let's do the same thing for just regular logs. I'm going to put it up at the top here. So log of any number with a base of itself is equal to 1. So like log base 2 of 2 would be 1. The other one is log base 10 of 1 is 0. So those are important facts to know. They'll help you when trying to simplify things or solve things or stuff like that. So those are all little key notes to make sure you have written down somewhere. All right, I'm going to let you guys work on the rest of them, give them a try. Again, the ones I left for you, some of them require multiple steps in order to condense or expand. So try them out, see what you can do. Don't forget to scan and upload to your Google Docs.